Let us evaluate the integral of e to the power minus x square cos of 5x dx as x changes from 0 to infinity. We will be applying Feynman's technique of integration or the method of differentiation under the sign of integral. You may speculate that we will just do it by integration by parts. Let's try. So we got the product of two functions e to the power minus x square and cos of 5x. And we take the first function to be equal to e to the power minus x square and second function to be cos of 5x dx, and we know that a product of two function, integration of product of two function is given by first function times integral of second function minus integral of derivative of first function and then integral of second function. This product has to be integrated once again. So we apply the same thing. Observe that integral of cos 5x is sin 5x by 5. Integral of cos 5x is sin 5x by 5. So this is equal to first function e to the power minus x square. Integral of second function is sin 5x by 5 minus integral of derivative of first function e to the power minus x square, and the derivative of minus x square is minus 2x. We apply chain rule. And then integral of second function is sin 5x by 5. See that we are stuck. We are getting much complicated expression. So what we do is we do not follow this approach. We simply go by Feynman's technique. So we want to evaluate these integrals. Instead of writing 5, we write b here. So this, if we change the value of b, then the integral changes. So let's call this expression to be equal to ib. We are writing ib, that's because if we change the value of b, the integral also changes. Now what we do is we differentiate both sides with respect to b. So we are differentiating left hand side with respect to b, and we are differentiating right hand side with respect to b. Now let us recall that integration symbol is just a long s, or it's just a sum. And we know that derivative of sum equal to sum of derivative. So we do same thing here. Derivative of integral equal to integral of derivative. But you see that there are two variables inside the integral, x and b. So what we do is we differentiate partially with respect to b. So what we did, we take the derivative inside of the integral. Is this valid? Yes, in most of the cases it is valid. And next what we do is we differentiate with respect to b. See, e to the power minus x square, that's just a constant when we differentiate partially with respect to b, so it doesn't change. So we just write it. However, derivative of cos bx with respect to b, remember we are differentiating with respect to b, so derivative of cos is minus sine of bx. And then we need to differentiate bx partially with respect to b. Remember, we are differentiating partially with respect to b, so we are regarding x as constant, and derivative of b with respect to b is just 1, so we just write it as times x. Rest of the expression we copy as it is. Let's rewrite this expression as minus, we can write outside of the integral, so minus of integral of sine of bx and then e to the power minus x square x separately, e to the power minus x square and then x separately. Now we apply the integration by product formula. So what we want is, we want to evaluate this integral. Did we simplify the process? It appears that we have made it complicated, but you will find that we have actually simplified it. So what we do is, we evaluate I equal to integral of sine bx and then e to the power minus x square times x dx. We will regard u to be sine bx and b to be e to the power minus x square times x dx. Can we evaluate the integral of e to the power minus x square times x dx? Yes, we can. So observe that integral of e to the power minus x square with the product x dx can simply be written as half of integral of e to the power minus x square d of x square. D of x square is 2x dx. So it is something like integral of e to the power minus u du, that's equal to e to the power minus u by minus 1 by 2 as it is, of course plus some constant of integration which we will not be writing. Now let us apply product rule. First function sine bx, integral of e to the power minus x square and x dx is the product e to the power minus x square and x dx is minus half of e to the power minus x square. So integral of second function is minus half of e to the power minus x square minus integral of derivative of first function, derivative of sine bx with respect to x is cos bx, and then we need to differentiate bx with respect to x as well, so that's just b. And then integral of second function, integral of e to the power minus x square times x is minus half of e to the power minus x square. Okay, that has to be integrated once again. Of course, we got the limit to be 0 to infinity. So we write from 0 to infinity and then 0 to infinity. As x approaches infinity, e to the power minus x square approaches 0. So this upper limit is 0. As x approaches 0, or in fact we can choose x equal to 0, sine 0 is 0. How about this one? Okay, let's simplify it. Minus minus gets cancelled. Negative of negative is positive. So we can write b by 2, 0 to infinity, cos bx, and then e to the power minus x square, e to the power minus x square dx. That's equal to di db. Remember, we started with di db. So you find that di db, and further observe that this integral is same as what we are getting now. So we can write di db equal to di db is exactly equal to b by 2 times I. We get a much simpler expression, right? Yes. Can we solve for I? Of course, now we will integrate it. So what we do is we simply write it as di 1 by I di equal to b by 2 db. Do you know how to integrate it? Of course, yes. Integral of 1 by I di is log of I. How about b by 2 db? Integral of b is b square by 2. And then half as it is. Of course, plus some constant of integration. This can simply be written as I equal to e to the power constant is another constant, let's call it c1, e to the power b square by 4. Now if somehow we can evaluate the constant c1, then we know ib. Can we do it? Of course we can. Observe that ib equal to integral 0 to infinity e to the power minus x square cos of bx dx. What if b equal to 0? However, I0 equal to integral 0 to infinity e to the power minus x square dx. Yes. And that's equal to root pi by 2. So we write b equal to 0 and say that I0 equal to c1 times e to the power 0 is 1. So and that turns out to be root pi by 2. So we can say ib equal to, instead of c1 we can write root pi by 2 e to the power b square by 4. And what is ib? ib is the integral 0 to infinity e to the power minus x square cos of bx dx. And that turns out to be root pi by 2 e to the power b square by 4. Now we are asked cos of 5x dx, so we choose b equal to 5. Choose b equal to 5 and say that integral 0 to infinity e to the power minus x square cos of 5x dx equal to root pi by 2 e to the power 25 by 4.